Hi guys, today I'm going to talk about backtracking. It is an example of uninformed search on AND OR graph, and this is the example of backtracking on AND OR graph. So let's begin, and there are you can see there are four figures. So these are all the same figures where we follow this backtracking. So first is this graph, and the bold part is the path of the traveler, and these dotted lines means we delete this part of the graph. So what happens first is, we begin with the root node and we go to the first node, then we go to the first child, then we go to the first child, and you see U means unsolved and S means solved. So this is unsolved, so this means so if this is unsolved, then we go to next, because this node is solved if this or this is solved. So this is unsolved, so we go to next node that we see in B. So since this is unsolved, we can delete this part, and it's deleted here. And we go to this part. For this node to be solved, either this or this should be solved, but this is also unsolved. So what we can do is we can delete this part. Then since this node can only be solved if this node and this node is solved, because there is an AND connection. See, this is an OR connection, this is an OR connection, and this is an AND connection. And since this node is not solved, this means this can be also unsolved. This is also U. So if this is U, then this is being an AND connection, this will be also U. So we can delete this whole thing. This whole graph can be deleted, and we get this. So we again track back to the starting from where we begin, then we go to the next child, and we go to the first child, we go to the first child. This is solved since there is OR connection, so we don't need to look this, so we just say this is solved. Then we go to this node, and this is an OR, this is AND, so we need to go to the next node, and this is solved, so this whole thing is solved. So on the way we can also delete the things that are solved. So in this way this AND OR works. So finally we have the path. So this is the path.